Okay, now I'd like to invite our panelists to join us. We'll have Travis Scott from Inductive Automation. Yes, please come up. We have Tárik Siqueira from Radix. Please join us. And I apologize for not having his photo on the screen, but he's a veteran of this particular session. And the one that I mentioned that had no money and was creative, Jason Hamlin, formerly of the City of Lynchburg Water, now with Corso Systems. Please join us, please, Jason. Put your thinking caps on while we have our panelists tell us in about 2 minutes or less what your company does.
Okay, I'll start. So hello, everybody. I'm Travis Cox. I'm co-director of sales engineering for Inductive Automation. So we're a software platform provider for HMI, SCADA, MES. And for us, it's really all about interoperability and open standards so that we can make these kind of convergence possible.
Thank you.
Hi, I'm Tárik Siqueira. I'm the downstream and chemicals business manager for Radix here in the US in North America. Been working with Braskem as one of our clients. Radix is a solution provider. So our approach is we leverage our technical knowledge in engineering, automation, and IT. So really bringing that convergence together to actually provide solutions. So we typically view those technologies as just tools to achieve a goal, to put together a solution that will solve a problem, a challenge, and will create value to our clients.
Thank you. Jason?
Jason Hamlin, City of Lynchburg. It's been a while. With Corso Systems, senior system engineer. We are a system integrator, and we leverage disruptive technology, non-traditional methodologies to accelerate business intelligence for any of our customers bold enough to think different.
Okay, think differently. I like that. Okay, so while you're still thinking out here, I'm going to start off with a question. I'm looking at our speakers here, Drew and Gustavo, and I'm guessing that you're definitely not boomers. And you're doing some really innovative things in your organizations. And I'm curious what your workforce mix is like and how that mix of skills and age groups and whatever else, I'm curious about the diversity and the acceptance of the technology in doing things differently.
You want first? Or? Okay.
All right, so I'll take that one first. Niagara is actually really interesting. Our headquarters is in Los Angeles, California, which is known for its diversity. And I think the mean age of employees at our company is, we may have just crossed into the low 30s. So we're a pretty young company. Our CEO took over when he was in his mid 20s, and he's now in his early 40s. So we're a very young company. We think about new technologies. We think about changing methodologies. We try to eliminate tradition for tradition's sake and innovate. And that's what's really kept us kind of at the forefront. So I would say our plant directors at each facility operate very autonomously, and they have a specific set of goals. And if they think that a new project doesn't help them achieve their goals, that's really the only resistance to new technology that we have. But my team, the digitalization team, works very hard to only work on things that add value and that are proven. And so we really don't have a lot of pushback to adopt our technologies.
Thank you. Gustavo?
I think we are in the learning epoch. My example, in the beginning of the project, I understand that the traditional approach and the traditional way to do the models was the only true. But through the project, I learn more about, I study more about the agile methodology, machine learning, these things of digital transformation. And now I understand that we have other ways to do models, for example, or to do initiatives. So it's complicated to response to answer what is the skills, what are the skills, because I don't know, and probably we'll discover skills that we need. So this is the main challenge of digital transformation, in my opinion, is this new culture, how to deal with these new technologies and how to deal with this way to study new things. So my opinion is this.
Thank you. One of the things that your presentation drove home to me is that, and I've struggled this even in my personal life, because I'm a bit of a perfectionist. So this technology, what you presented to me, is you have to kind of let go of the perfection sometimes and know when good enough is good enough. Would you have anything, thoughts on that, Gustavo?
Yeah, I agree, because I'm not a leader right now, because I love this how to deal with this new digital transformation, use engineering in the essence. Because, for example, we developed some models for polymer plants in the first models in 1996. It's almost the same approach, but it's totally different in the development. So I believe in this digital transformation. I'm enjoying enjoy it almost the end. Enjoyed all the discussions. So I believe in this.
Great. How about with our panelists? You deal with a broad range of customers in a lot of industries and locations. Are you finding that the acceptance of technology varies depending on who you're talking to or the culture of the organization? Does that all have an impact on what they are willing to implement from your perspectives?
So I definitely think there are industries that are more forward and industries that took more time to accept and to start adopting it. I do think the age difference generations also does play a role into how they typically view this. But I think in the last couple of years, I believe the digital transformation already reached, at least in my industry, which is the downstream of chemicals, already reached all the major players, and we're seeing all of them. Braskem, for example, setting up digital centers, digital teams, gathering their own digital data science team too, and that's as well what we did inside Radix. And one key success that we've had, I think, is keeping that domain expertise. So even though, as Gustavo mentioned, in that project we had engineering teams, we had software teams and data science teams, most of our software guys or the data science people, they do have engineering background. So that does help a lot them to understand what the problem they're dealing with is and help them be successful in that project.
Thank you. Travis?
Yeah, so I can say from our experience, definitely it's all about how the customer approaches these kind of projects. It's really the technology set is there. We have there's amazing things you can use, but it's about the people. I think the most important part of yours is getting the buy-in from the right people, getting the different teams to understand the business goals, the values that can be brought out of it, and have them be part of that project. To really think that they're bringing a lot of value to the company. And, that's kind of the idea of, this OT-IT convergence, if you will, right? Where in order to really make that successful, you have to have buy-in from both sides and have to be coordinated and align, have executive buy-in as well, because then they can see this is a real thing. I think that's just the most important piece. Once you have that, then the technology can fall in line.
Yep, agreed. Jason, you kind of have a unique perspective as being the middleman there as the integrator. What do you see?
I agree. It's definitely depends on the company and depends on the culture. For my company, I'm the oldest, actually, talking about that mix. So a bunch of amazing 20-year-old coders will go in and do great stuff, but in the wrong type of environment, they will scare people. You know, when those kids show up, tattoos, headphones, right, and they're ready to just do amazing work, and that's not the culture of folks wearing suits. It's the culture of folks wearing hoodies. So to bridge that gap and show these companies that this younger, newer mindset can bring and leverage amazing technology, it takes somebody to help bridge that gap and help lead them there. And then once you do, yeah, the transformation is incredible. And once they start to see those ROIs, they start to really understand that they can think and do different.
Great.
Paula, I do have one more thing to add on that.
Sure.
I think one of the reasons we haven't had a lot of internal adoption issues is because of the technology that we select. We are not working with a lot of legacy vendors. We're working with new innovative companies who have that mindset. We heavily rely on Ignition that inductive automation makes. We have it in every plant, and we have 5 more servers sitting at our corporate facility. And then, the sensors that we use, the manufacturing equipment that we use, they're all from innovative companies that have that new mindset. And so that reassures our internal stakeholders as well that, the technology we're implementing is not going to be that old mindset, non-innovative or wasteful in some cases, but the companies that we're implementing are thinking dynamically as well. And so that's been a huge benefit for us.
Good. Okay. How about our audience? Anybody have any questions for our speakers and panelists? No? Oh, we have one.
Andrew, was your
Could you hold on just a second till you get a mic, please? Do we have a mic? Oh, yes, we do. Thank you.
Andrew, was your implementation on a greenfield, or was that from the start, or was it retrofitting as you went along?
For which project?
For your bottling,
For our bottling?
manufacturing.
So very early on in our company's history, we had acquisitions and partnerships, but primarily we build all of our own facilities, our own lines. Our lines are actually all experimental equipment. So we don't have any commercially available equipment. It's all experimental. Yeah, it's pretty exciting.
Okay.
That comes with its problems too, though. I just have to say that. You have to be careful.
You care to expound?
Yeah, I mean, sometimes we over-innovate. We'll pick a specific process and we'll try to innovate too much in that specific realm when really we could be looking at something else or a combination of other things that would provide more value more quickly, even though there still is some value in whatever we're working on.
Okay. Thank you. Anybody?
Yeah, this Gustavo. You had the machine learning kind of process slide that up there, and cleaning was part of that. So my first question has to do with how much effort you spend on cleaning the data before training.
A lot of, because train models is easy to do, but prepare data, select the periods, select the variables, understand the behavior, to understand after the training if you have a correct direction of the response, is the heart of development in machine learning models. So I understand that in this step, we need more effort. We need more areas involved. The process knowledge need to be discussed in this phase. And after, it's just train models and select the type, the technology to use of modeling. and understand the response and validate the models. But the first step is more than 50% of the development of models, in my opinion.
Okay. And then the second question is that, do you just go through that process once, or do you update that, or is it a continuous refinement?
Yeah, it's a continuous refining because we have changes in the process, have changes in the market, and of course in the amount and the properties of the products. We created a new workflow and with new roles and of the team just to keep these models up to date. So it's a new challenge from now is how to keep these models useful.
Thank you.
I think that's one everybody's going to be facing. Anybody else here want to jump in on this one?
Yeah, I'll add to that. Between this project and other projects we're doing using machine learning models, one, for example, predictive maintenance, we also presented on Tuesday here with Braskem. We find that these industry is calling machine learning operations, MLOps, is a part that's often neglected at the beginning of the project, and that is something that should be thought of at the design phase, right? How are you, because as Gustavo showed, we had 57 virtual analyzers, but in total we had, I think, over 200 models. So, and that's just for some of the plants they have. Of course, the plan is to expand that, roll that out throughout all the plants. So between other projects, you could be talking about maintaining thousands of models. And so it has to be a concern about how do you keep them updated. There are new tools on the market, but you got to establish, a process, a change management, and train your personnel to keep those updated whenever needed.
I'll just reemphasize what Gustavo said. I mean, training the model is a very, very easy part. Deploying it back into production is actually also kind of easy. Getting the data that you need and making sure it's clean, consistent, useful, that's the incredibly hard part. I mean, on one of the projects I mentioned, we didn't even have the right data point. We did a root variance analysis, and I didn't even have the right data point. I had to go physically add a sensor to be able to do machine learning. So that's definitely the hard part.
Complete, accessible, current, and trustworthy. Yes.
Just another point. To do a model, my opinion, if the model is linear, the response is linear, 2 points is enough. For a non-linear, my opinion, 3 points is enough. The secret is find these 2 or 3 points. In the data cleaning, this is the main activity to do.
Anybody else?
Machine learning, our company is doing some work with machine learning also. You have to learn the right questions to ask and how to work with your data, right? So when someone says 7 plus what equals 3, an elementary school student gets confused. That math doesn't make sense to them. But you get a little older and you know 7 plus negative 4 equals 3. The math makes sense. Machine learning delves into the realm of where you're saying 7 plus what equals purple. It almost is a type 3 error. It almost doesn't make sense. And sometimes you'll get an answer, and you need to know if that answer even makes sense, because sometimes it doesn't. You can throw data in uncleaned, get these models, get answers back that are useless or way off track. When you're starting to bring that into a control system, you're introducing that major amount of risk, right? I can't let, if I have a machine learning algorithm that says, oh, 7 plus whatever equals purple, let's go ahead and change the parameters of a running system, you could kill somebody. So these are real concerns. But that fear can't stop you from moving forward into machine learning and AI algorithms. You have to find ways to learn and refine and test these models. So that's what we focus on strongly, is helping understand the processes. And that's what customers really need to be looking at.
I'll just expand real quick on, definitely right, and trying to figure out what questions you have to ask. You also have to have the right skill set with these kind of projects. You have to have buy-in from the operations team who understand, who've been working on that process for forever, who know all the physics and mechanics of it. You then need the deep data scientists and machine learning understanding of all different algorithms and how you can apply the algorithms. I mean, not only cleaning data is important, but then you play with tons of different algorithms and you figure out which one is most appropriate for your process or for what you're trying to solve. And that can be a challenge if you don't have the right team on, the right folks that are all working together on that.
Yep.
There's no one single person that's going to be able to do all that. It's going to take a large team.
Yep. Agreed. Okay, how about a question from the audience? We have one.
Thank you, Paula. Thank you all. I just have a question for Braskem, Gustavo. My name is Hamza Hamada. I'm from Aramco. We have a practice for the governance and also the monitoring of the quality of operational data, where we try to unify the units, engineering units, the way even the string data, and also the way the numbers, decimal places, and the compression rates, and all of that. I would like to hear more what Braskem is doing in that aspect, considering its importance to AI deployments. When it comes to operational data, you have a lot of plants, a lot of data. How do you govern that to minimize data cleaning?
Sorry, would you repeat the end of your question?
Yeah, I'm sure that you have a lot of facilities and a lot of data for each facility collected in historians.
Mm-hmm.
How do you govern the quality of these data to make sure when you do AI deployments, there's minimum front-end effort, or let's say overhead for data cleaning and all of that? Is there like a process, some kind of reporting, best practice, or a standard within Braskem?
Mm-hmm. Good question. In this project, just an idea, we are talking about more than 9 billions of points, because a lot of years, a lot of plants, different measurements. So it's a lot of values to deal. It's a really big data. To find the 2 points is not so easy around these 9 billions. Your question is very interesting, because we are not prepared to manage this amount of data, because we have different origins, sources of this data. We don't have a centralized for a while system to see the data, to manipulate the information. So we have some projects in the digital set of initiatives to have this data centralized in one system, at least the basic values that we need for other projects. But we are walking for a while for this direction, because send this data to an Excel spreadsheet and manipulate with these files in Excel is not 4.0. Is a traditional approach. So we need to walk in a way about this data management, in my opinion.
Thanks, Gustavo. If I can add to that, data quality is a big issue that a lot of our clients are facing, and just configuring exceptions and compressions are typically not enough, because even if you have all of that set up, if one instrument fails, but it's still sending data, those rules won't tell you, hey, this instrument failed, it's sending me bad data, right? It might tell you if that instrument stops sending you data, but not if it's sending an incorrect value. So we're working on a few clients to try to apply analytics to do data quality assessments in real time. Because, as you said, you might have dozens or hundreds of plants, and that will become millions of points. And there's no way you can manually be cleaning all that data, every day. So it needs to go to an automated route on trying to detect and maybe clean that data automatically.
But data quality, I have a thought on that too, because I'm going to borrow a phrase from a friend of mine who presented here earlier. They say you can do the data quality as it goes into the lake or as you take it out of the lake. And he said, no, we want to do data quality upriver in the stream before it even feeds the lake. And that's a true statement, and it really matters. And when you're dealing with millions or billions of data points, data quality becomes exceptionally important. And when I said, challenging for customers to think differently and for businesses, this particular customer has a data quality department and took a step further, and us as contractors working on a major data migration and historian project actually is paying us to sit in on some of the meetings with the data quality team. They have us involved in that at the onset because it's that critical to them, and they realize just how much of a difference that data quality makes from the beginning. And it's that type of thought process that really will lead to absolute innovation and change for them and for anybody else.
Interesting. Data quality department. I'd never heard of that one before. Anybody else want to jump in? No? Okay. How about back to our audience? Any more questions for our panelists? That's not good. I can't let you go yet. Himanshu, could I ask you to go back to my presentation, please? Oh, we have a question. In the
One
meantime,
question, trailing off of the data quality. If you have inadvertently cleansed data that might have otherwise given you a insight on an upstream sensor error or what have you, and you could use that for forensics. When you after you've cleaned the data, can you go back to the data before you've cleansed it? Do you keep that in some kind of repository, just loading up buckets of hard drive space?
So, I can take a stab at that. The way that we approach data quality is we store all of our raw values for a certain period of time. And then if we want to clean something or apply some logic or filtering to it, we do that and we store it as a separate value. That way we always have the ability to go back and look at the raw data. Because you're right, sometimes you do miss the insights or you overprogram your system to account for something that isn't actually happening. So that's kind of our approach. We keep it raw data temporarily and then process data permanently.
Yeah, it's the same for us. That's our general recommendation. And we typically try to target and use systems that have data quality somehow inherently built in. A lot of our projects, we leverage like inductive automation or Sepasoft for things that we're doing where, even OPC codes where it's storing data quality codes, and then we can take it a step further. And sometimes you can pull raw sensor data out, and then you can easily put that into a database as well. So we will store quality codes along with those data points so that if there's any suspect or suspicious, it flags it. But you never actually want to delete the raw data because there is value in that. Even again, feeding those predictive analytics, you can start to learn this sensor starts to show these characteristics and you can find it. Or in the case of my wastewater plant where I was at, we were having bad data quality, which actually led us to find a network card that was failing on a particular PLC. So something completely out of the realm of data quality, but something that was of value to us. So throwing away that data, we never would have figured that out.
Thank you. Anybody else want to chime in? No? How about a question? No? Okay. Anybody have any thoughts on the future? You agree with this or not? Are we still going to be doing what Don Bartusiak said, replacing the control systems from the 70s and 80s?
Paul, I would say to a certain degree, the future is now.
Well, agreed. I mean, when I saw the column 2010 to 2020, I thought, this is 2020. This is now. I have to have a future.
Yeah. Well, I'm saying specifically the things that you've listed in your future column.
You're already doing.
Some of them are completed and the rest of them are in progress.
Holy smokes. Okay, I'm behind the times. I guess perhaps I'm a boomer. Anybody else?
Yeah, I'd like to add, I agree with Don's comment. I think that will definitely still be happening 10 years from now, but I think the field's going to be mixed, right? You're going to have maybe new greenfield plants that might be in some of those future levels, but you still have plants that are old and are still running old systems. So I think it's going to be a mixed approach that you're going to see throughout the industry.
Okay. Jason?
Well, I like the one here that says appreciation of engineering. I'm still waiting on that.
Travis?
Yeah, I mean, I do think that there's still, if you look at Brownfield in particular, there's still a ton of data that's not even being looked at, stranded, and could be just because of a lot of concerns. You know, it could be anywhere from bandwidth issues, you know, and latency, or it could be anything from licensing restrictions, whatever it might be, where that data is not even brought in. I think goal number one, in order to really, we're going down this path. The future is now, but it's all about having the data. If you have the data, then you can get to these kind of things. So it's really about solving that operational side and getting access to all that data, making sure it's all there. Yes, you have to look at the data quality, all these things at the end of the day, but I mean, step one should be, can we bring it all in? Can we start really utilizing that data? Because with these kind of machine learning systems, you don't even know what kind of data you need until you start getting into it. You know, all of a sudden, you need this data point. It's going to help you train that model better. And you need this one or some external factor that you didn't even think about. So anyways, I think for a lot of what we're helping customers is just really getting access and doing it from the edge in a very efficient way, bringing it back to these systems and allowing it to be used across all systems. Can't just be locked into silos.
Okay. How about from the audience? Anybody have any thoughts on this? Please.
So looking at the skills required, you see it goes from instrument tech, process automation engineer, and then we get up to proactive problem solvers. As you see people get more involved in doing the digital things, doing these more things that look more like IT, do you see your workforce losing the basics and trying to apply really interesting digital solutions to problems that may be able to be solved very conventionally just because they don't have that basic insight?
Anybody?
Short answer, yes. No, it's absolutely true. I have a coworker who's geniusly gifted at scripting in Python and what he can build and do, and he will overcomplicate anything and everything. And I hope this is not recorded because he'll watch it and yell at me, but I won't name him. But it's true, right? And so I am not a boomer, thankfully, but still oldest in the company. I came from that background. I know ladder logic, and I turned screwdrivers for a long time. I still proudly hold my electrical license and keep it current, even though I never use it, except for friends and family when they want a fan put in their house. And now I'm system engineer. Everything I do is in front of a computer. Everything I do is sitting there. And our newest hires and our newest people we're pulling in, they're really coming from a computer science background. These are scripters and coders who have found that automation is fun, and they're working in that. And they have never seen ladder before, whereas I hated structured text. It took me a long time to wrap my head around that. They don't know what ladder is. They certainly, Phillips screwdriver, they're lost. They don't know what that is. No disrespect to them, but yeah, those basic skills are being lost on them. So troubleshooting becomes interesting because if you're trying to troubleshoot a holistic control system from the sensor forward, there's an entire skill gap that they're missing. So we do try to find people that can help with that, or you have to work with or partner with companies that can. We routinely stress, do not devalue those field workers or the E&I shop at the plant you're working at, because you need that domain knowledge. And there's a real fear that we could lose it as everything goes fully digital.
Anybody else?
Yeah, I'll say we have a big emphasis on that at our company. And I think our approach has been we have people who focus on maintaining those skills, and a training department, a technical training department that focuses on retaining that knowledge and even still finding ways to innovate within those areas of the basic skills. But I will say it's very highly valued, and throughout the industry as a whole, I think we are losing that. He's right. So companies value that very highly.
Okay. Oh, another one.
I think it's missing data science. And I think we have seen in the past few years that the approach of having dedicated, fully fledged data scientists is not working. So I've seen that even within Aramco and other companies, as a best practice is to redeploy engineers with domain knowledge, with some training on data science or maybe some advanced courses. But I think that's one of the skills that's absolutely required now. And also something that's kind of confusing, or I would say I have mixed feelings about as a professional and in the industry. I think one of the key successes of oil and gas, at least for the past decades, was specialization. You have people who are specialized in a certain area, focused, they know in depth what's in that field, be it in automation, be it in civil structures, whatever. But unfortunately, digital transformation now is driving us to a point where you want to have more and more jacks of all trades.
Yep.
We call them more breadth than depth, more flexibility in learning. I wouldn't say, unfortunately, I would say it's a fact. We have to adapt to it. We have to get the best out of it. And there are a lot of new fields. So I think one of the key skills is learning quickly and independently. There are so many skills that are coming out, and we cannot even catch up with having who is supposed to do this. We end up going with the interest. People who are gamers privately, in their homes, they end up doing AR, VR for us, and the like this. So I just thought about throwing my 2 cents.
No, perfect. Thank you. If we were a baseball team, we'd be looking for that utility infielder, I think, if I could use that analogy. Thank you for that.
Yeah, and may I just add a
Yes.
comment to that? I totally agree. And as I said in the past here, that's the approach that we take within Radix. So most of our data science team has the engineering background because they're able to understand the domain. This is a change that the company itself did, years ago, also on a structure organization. In the past, even though we always were concerned with the solutions and we used the technology as a tool, we were structured in engineering, automation, and IT or software development. And nowadays, our structure is actually towards the industry so we're oil and gas, metals and mining, pulp and paper, and so on, because our focus is understanding our clients' business challenges and helping them solve it. What technology we're going to use is a second step. The first thing is understanding that and having the domain expertise to really solve it.
I'll just add one quick thing, which is, I think one thing that's really important for our industry at large, especially, is a lot of the big end users and definitely vendors need to be contributing to education early on to the next generations coming in, and providing the tools, they need to have a small manufacturing process, in their hands that they could be working on to learn how to use a screwdriver, to learn then how to apply that to machine learning and so on. We have to be able to supply that and really focused on making sure that they're coming in.
Great.
Yeah.
I want to thank.
Give them
Okay.
all a Raspberry Pi. Like seriously, just hand your young out of college kids a Raspberry Pi and say, "Here, build me something cool with this." And they at least learn how to use small screwdrivers.
Very good. That's why I love you, Jason. Okay, I would like to thank our panel speakers so much. Very insightful. How about a nice round of applause for all of them?